Salam alaikum. Hello everyone. Welcome back to the part 2, that is the writing part or the free response question, that's called FRQ, for the EOT exam questions. This is for grade 12 advance, and the writing part for you guys is from question number 16 to question number 20. Please make sure you write everything in detail. Write the given, write the formulas, solve, do the steps. This is very, very important to write everything and then get the answer. Some of the problems can be done directly in calculator method. You can only use that to check your answer. But if you directly write the answer from calculator method, you will not get the entire marks. So please make sure you write each steps in detail. Even if you have forgotten some steps, don't worry. Try to understand what's going on. Try to continue from where you can and write things in detail. This is very important. Now we'll begin. Before we begin, I just want to quickly remind you, if you're not yet subscribed to my channel, please do consider subscribing it. It's this link over here, or you can scan this QR code. It would mean so much to me, and I appreciate and thank all the subscribers, all the support which I've already received. Thank you so much, guys. We will move on to the first question in the writing part. That is question number 16. We have to use the squeeze theorem to find limits and find limits at infinity and limits that are infinite. So there are two different types of questions. The squeeze theorem is an important one. Here you can see this. There's a question given to you and we have to apply squeeze theorem. But before that, I'll just tell a little bit about squeeze theorem. Now, let me write it out over here. Imagine you have been given this function, right? F of x. Okay. No, wait. Sorry. This is. Let us consider this as anything. Okay. G of x, because f of x and h of x is already given over here. So we are considering it to be g of x. The condition is g of x must be less than or equal to the function h of x, a greater function, and that must be greater than or less than another function h of x. Now this is the condition. See, that's already given. This g of x is the given to us, x squared sine 1 by x. That is in between f of x and h of x. In such cases, if at all we apply limits to all, let's first apply the limits to the outer functions. If we apply limit to any point, whichever point is specified in the question, it can vary, say f of x, and this also over here, limit as x tends to the same point where we are applying limit, a itself. It can be any number, 2, 0, 5 or anything, okay? Now here it's h of x, okay, this thing. If these two are equal, okay, say any number, these two are equal to, say I will write it as m, then this g of x, right, when we take limit to the same point as x tends to a, must be equal to the same value m, because this is equal to m, this is equal to m, that is the lower and the higher functions, then this point must be equal to that point. That is about squeeze theorem. That's the thing, because you're squeezing this in between the two functions, and when you take the limit, this must be the answer. And if you look at the graphs, it's like squeezed up graphs, say like these difficult functions are being used by squeeze theorem, because it's very hard for us to find the limit for these directly. So now then, let's use the concept over here. There are a few things over here. See, this x squared is a polynomial. So leave that, multiply it later on. See what is sine, like the base function, okay? Really, we should know a basic thing of splitting the function. Now, if it's x squared sine 1 by x. So use this function, because we know the range of this function. The range is very, very important. We need to write the range. And one more thing, in the question they have already mentioned, look here, the limit of this function f of x, lower function with the higher function, is equal. Then we can apply squeeze theorem with the statement, okay? Now here, we need to know the range of sine. What is the range of sine? It is, what power is this? It's 1, 1, 3, 5, all the odd powers, the range is same. My even if it's cos also is the same thing, 1 and 1. It can be only with 1 and 1. If you go to Desmos and graph it, you will realize, oh, okay, the graphs only go from 1 to 1. Okay. Now then, this sine 1 by x must be greater than negative 1 but less than 1, isn't it? Then here we have not multiplied the x square, isn't it? So what do we have to do? We have to multiply this x square throughout. We can't just do it over here. Now the range changes because x square is there. So now you have to multiply x square throughout this particular equation. In the sense, here it will be minus x square less than or equal to sine 1 by x was given already. Now you multiplied x squared. That is our question. Okay, the polynomial part we multiplied and over here it's x squared. Now then what we do, what is the limit they have specified? At x tends to 0, and you are supposed to find at that point only, because you can't have different values here, because the squeeze theorem clearly states all the limiting point must be same, right? So now just find the limits everywhere. If I do limit as x tends to 0, here what is the function? It is minus x square less than or equal to, over here also limit as x tends to 0, x square sine 1 by x as less than limit. I'm just writing this because it's all writing parts, so we can write it in detail. Okay, we are just taking limit everywhere. Now you don't know the limit over here, don't find the limit, but you can check it and calculate it later on, but that do not need to be written. What is the answer here? Limit, substitute 0. It's very simple polynomial. It's 0 over here, and over here what's the answer? 0. And over here the middle one will be limit x tends to 0, x square sine 1 by x. Didn't you get the answer now? It's 0, isn't it? Now before this you can write this, but then there is one more step required. You have to mention, see this, whatever is written, because this is f of x, right? F of x, h of x. So just mention this part. Okay, I'll write it. Limit as tends to 0 f of x is equal to, they have already mentioned, and yes, we got the same thing, h of x, okay, is equal to 0. Therefore, from squeeze theorem, I'll just write from squeeze theorem, what you do is limit x tends to 0, x square sine 1 by x will be equal to 0. So this is enough, I believe. This is basically squeeze theorem. Now personally, if I was correcting, if I have seen this, I would give you full marks because that's the answer. Now let's look into the, okay, use numerical. See, now this is the formula method. Okay, this is what is technically what is really a squeeze theorem. Now in the solution set they have given you the graph, this thing. Graph, practically it's not possible to do it, you know. If you ask me to graph, it will take me ages. I mean, taking this, it's crazy. I would just not do that. This is the main part. Okay, now this must be there. This is what is exactly squeeze theorem, what we just now did over here and over here, right? So I will just mark the steps. You can just go and watch the video in sequence. You'll understand. This was step 1, 2, 3. This can be written later also, but just write it. 4, 5, 6 is this, and lastly 7. Okay, 7 steps are there. Now see, there are some steps which you can skip. This you do not need to write, you can directly write, but if you understood the problem, you write it out, it's fine, you know. If you understood, yes, this is understood, easily understandable. So that's the thing. And now let's go through the solution part. This much is more than enough. The final answer is 0, and you can see the answer over here is also 0. Okay, now let me explain you what this is exactly. Here basically you're taking x values or x square values, and no, it should be practically x values, solving for it, put in radian mode, solve the values. Different x values. See, it's because squeeze theorem is a very, it's not like 1, 2, 3. It's very, very tiny, isn't it? So it's all 0 0.1 and so on. So you're taking small numbers, left of 0, right of 0. And then you're finding this and you can plot this curve. But honestly speaking, this graph would just be too much. It's just crazy, okay? But I believe that they are going to ask you the numerical evidence. Now here they have not done much. They have directly given you the answers, in the sense they have just told this is x squared. Why? Let f of x is minus x squared. Why do you get that? It's not clearly mentioned. They have just told, okay, from squeeze theorem, this is the thing. So that's why please follow this. Why we are getting x minus x squared and x squared? Because the range of sine 1 by x is minus 1 and 1. And then we have to multiply the polynomial part. And this is the given question. Now then you have to apply the limit both the sides, all the sides, and then find the limit at the lower function and the higher function. And if those two are equal, then the middle part must be equal to that. That is the point of the squeeze theorem. I hope this is clear. So that's it. We will now go to the next problem. Now try to do it by yourselves. Oh, by the way, it's secant. Now, if this is asked for me, I would just not do it because secant graphs are very crazy graphs. But they're telling why can't you use squeeze theorem? That means you can't. Yeah, you just can't. Look at the graphs. It's very, very hard to specify or find it. Whereas they have what they are mentioned over here is it first thing, it's not bounded by anything. Whereas sine graph, what was sine graph? It was always bounded. So it was bounded like this, right? There was a range to it. But this is not bounded, it goes to infinity. So it's basically, you cannot do it, and there are infinitely many vertical asymptotes approaching as x is 0. But don't worry, this should not be asked. But even if they ask you to just tell it's not bounded by any certain specific region. Over here, sine and cos graphs are bounded by this minus 1 to 1. We had applied just a while ago. See, minus 1 to 1. It's bounded over there, but this is not. That's why. But I don't think so this will be asked. Let's see. This might be asked. It's cos squared. But there is one important thing to do over here. What is the range of cos squared? Think for a while. Range of cos square is cos square 1 by x is not minus 1 to 1 because it's squared. You can't have negative value, right? Here it becomes 0 to 1. That's the only thing. Okay. And again, they have not mentioned that at all. So let's do it in writing because that is not good enough, whatever is there in the solution part. So follow what I'm doing now. And this can be related and you can solve any other problems as well. Here, the range of cos square 1 by x is, it should be less than or equal to 1 or greater than or equal to 0. So how would you find the range? You can either graph or you should just remember whenever it's even powers, this is the range, okay? For cos, sine 1 by x, cos square. Sorry, it's not cos sine, it's cos square sine x square or to the power 4 or any even powers, okay? Now then, this is it. But look over here, there is root x. So what you must do is you have to multiply root x on both the sides, all the sides, sorry. That time you will get this given question. And this is a squeeze theorem. See, they have told f of x is less than or equal to this given function and h of x is greater than that. And the limits of both those at 0 plus is 0. I'll tell you why this plus will be there. I think so because it's square root, Otherwise, the limit does not exist. But let's solve it in a minute. Then we will come to know in a minute. After this step, this is the given formula. What we do here is multiply root x throughout. So root x multiplied by 0. It will be 0, but still just multiply it. Here, root x into cos square 1 by x less than or equal to root x times 1 is root x itself. Now, let's do it anyways. So this is what you do. You multiply root x, this polynomial part, throughout. Now then, solve it. This is 0 less than or equal to root x cos square 1 by x less than or equal to root x. Now let me do little variation. Let me directly apply this, the formula. See, now I'm just, okay, they are telling you to justify. I thought this is given in the question. If this is already given in the question, this and this is 0, that means this middle part is equal to 0. You don't even need to do anything. But since they have told justify, you need to make sure you solve it up, okay, like this. And now you're taking limit. Just take limits on this and this. Now the ends, okay, limit as x tends to 0 plus of 0 is equal to what? Limit of this is 0 itself. Now take the limit over here. Limit, this is just a little bit of variation from the last problem. You can have a little bit variation. You have the freedom to do that. It's up to you however you write it. As long as you know the concept and write correctly, it's fine. Now this is limit as x tends to 0 plus root x. What is the limit? Here, why there is no 0? Why it is 0 plus? Because if you imagine you just take 0, what happens? From the left side, this is undefined. So there is no limit. Limit does not exist. Here, because there is root x, you can't have x values less than 0. It must be greater than 0. Okay? That's the reason. And also about the continuity, it is not continuous and differentiable if it's not greater than 0. Now anyways, here what will happen? From plus it will be 0 itself. So these two are same, right? Here now you write since limit as x tends to 0 from the plus side, this 0 is what? F of x, okay? F of x. Because we have done this, it's understood. Oh, one more thing. You can write one more part, the given part. This is given in the question. Sorry, I forgot to write this. Here you need to just write root x. So just write the question as well, okay? H of x. So even in the previous question, please do mention this part. That is the given. Whatever is given, first write that out. And then, we are starting to solve. Cos square 1 by x, the range we write, we multiply by root x and get this function. And then we start simplifying with squeeze theorem. It's very simple once you understand the concept. Since this limit, f of x, is equal to the limit as x tends to 0 from the positive side. For what now? It is for h of x, this next function, is equal to 0. Therefore, from squeeze theorem, we must have what? The limit as x tends to 0 plus. This is the question we are finding. As x tends to 0 plus of root x cos square 1 by x is equal to what? 0. That's it. So this is the answer. If you write so much, you have to get full marks. Don't go to graph it because you'll be there in the entire exam then. 1.5 hours for graph. I'm just saying that, it's not required. The examiner will understand. It's really show graphically. I have just no clue why they're asking you to show graphically. If you have a graphing calculator, it's fine. You can get the graph. But otherwise, it's very hard, it's not impossible. You can do it. Obviously, it's possible to do it, but it'll take so much time that I personally would not graph it. Even if I'm going to lose marks, it's fine. But I would just write this and move on to the other problems. Okay, and if you have so much time remaining, then try graphing it if there's mentioned it. I hope that's clear. And this is the answer. Please pause the video and see. Now I will write this step point wise, which was the first step. Here, this will be the first step. 1, 2, 3, 4, 5, 6. Then 7 is this one, since 8 is together, this 8 and 9 is together. So that is the steps you need to write. If you write so much, you must get full marks. And the answer is yes, it's 0. Now I was telling you can do it in calculator method, right? Yes, we will. I'll just show you what's the answer. Just take out your calculators and let's check. Here what you do is, say the given question. Let's type it as it is. That is root alpha x multiplied by cos 1 by x, 1 by alpha x, close the bracket. And now you need to square the entire function, because when it is cos square, that means the entire term is squared. Okay, let me just square it up over here. That's the answer. Now if you just press equal to, it doesn't make any sense. If you press calc and 0.001, still you will not get the answer. This is okay, it's almost correct, but really it's not. Why? Because cos is there. So shift mode and make it to radian. And now calc at 0.001. Okay, what happened? Calc 0.01. Let me just take small values. Yes, you're getting 0.07. Let me take a bit more value, 0.001. Yeah, you're getting now. If you just keep on increasing it, 0.00, as you increase, so you can see it is becoming more and more zero. It's 0.0009. That means it's corresponding to 0. That's why we can take the answer as 0. But this is just to check. And here, you don't even need to check. I just realized when I was solving the problems, the value is given. You have to just justify by writing. So that means the answer is already told. It's 0. Doesn't make sense by using calculator because it's already told what's the answer. You're justifying this. The steps what I had done, right? These steps justify your answer. This is how you justify it. Okay? And now on, please do try to solve these problems by yourselves because we have already solved the similar ones. Let's quickly see this. Suppose f of x is bounded, that is, there exists a constant m such that f of x is less than or equal to m. For x, use squeeze theorem to prove that x square f of x is 0. Okay, now the most important part is they have told constant m. So constant means whatever happens will be 0, right? So all you do is do the squeeze theorem. See, over here it's written. Okay, this one is written in detail. Now, f of x and x squared is there. But they have clearly mentioned the modulus of f of x less than or equal to m. That means f of x is less than or equal to positive m and greater than or equal to negative m, isn't it? Because that's modulus thing. It must be greater than, see this m, right? Let's write less than or equal to. Let's take the modulus out. Let's write only the function. But it must be greater than or equal to minus m. Now all you do is multiply x squared. Now multiply x squared throughout. Why? Because this is what the question is. So if you multiply x squared, it will be minus mx squared less than or equal to x squared f of x less than or equal to. I'm writing this m first because it's the constant. It's just a number like 2, 3, 4 like that. Or 1, minus 1, plus 1 like that. Okay. If this is 1, this is also 1 only. But it will be only sign difference. Now then, what you have to do? Take the limit of this at x square, right? Take limit. Both the sides. Now this side I'll take the first limit. Limit as x tends to 0 for minus mx square. What is the value? This is a constant. This will be 0. Its answer is 0. Now limit as x tends to 0 for the right side. Mx square. It's the same thing. It will be 0 because this is a constant. Now are these two equal? Yes. So you just write limit as x tends to 0 from minus mx square is equal to the limit as x tends to 0 from positive mx square. Don't you think? They are. So this is equal. So now what do we write? From squeeze theorem, this, the limit at x, whatever is given over here, is equal to 0. This must be written. But just write from squeeze theorem. Why? Because this is the lower function, greater function, and we found it out. So yeah, from squeeze theorem it is proved. Just write from squeeze theorem and this statement, whatever is given in the question, that is basically proved. I hope this is clear. Now in the previous ones we had to know the range. If this is a constant, it's very easy. You're just writing this constant and solving, right? There's nothing much. Now we move on to the 37th problem. This one is an important problem. Here, first of all, when you look at this, what do you see? You see a rational function, right? Let's solve this. How would you solve this? So always try to keep the polynomial outside. We can multiply that later. That's fine. but keep the rational other side. So the first step over here to solve this would be, what I would do is write, we have to use squeeze theorem to prove. So what I would do is I'll write 1 by x squared plus 1 and write the range for this. What is the possible range for 1 by x squared plus 1? Let's take any number, it will be greater than or equal to 0 and it will be less than or equal to what? 1. It should be less than or equal to 1. That is, if x is 0. Now, I will prove this by taking the calculator because it's easy to show you. Let's take out our calculators and let's understand this. Here, let's write this in the form of x itself. 1 divided by alpha x squared plus 1. Now, take any value for x. Let's start with 0. What is the answer? It's 1. Let's start with anything else, say 0.5. 4 by 5, that is 0.8. You can think of any number and just type it in your calculator. This is again 0.000. It's less than 1, but greater than 0. Can you have negative numbers? Let's take minus 5. Still it's positive. What's happening? Look, the variable is squared, so it doesn't matter it's negative or positive, it gets squared and it will become a positive value and it should be greater than 0. There is no way you'll get a negative value. And since it's divided by 1, doesn't matter how big this number is, it gets smaller. So when you divide any number by a big number, what happens? It gets, answer is very small. The same way, if you divide 1 by a very small number, very small number, say 0.00, it gets a big number, right? But here, what is happening? X squared plus this number, so it doesn't matter what is being, let's say for example, we'll take a very small number over here, but since you're dividing it by 1 and plus 1, see, let me take a very small number, 0 point so much, okay, square, but since you're adding that small number to 1, doesn't matter what, it will be 1 point something. So it will be very close to 1 itself. It can never ever exceed. Now, if you understand the rational functions, when you look at this, you should realize, okay, the range is 0 to greater than 0, less than 1. We have by hearted that, but this is the way to understand. Why? Because it doesn't matter which value you put over here in this case, it will be in this range itself. Okay? So that's the reason why, we did that for a while just now. I hope this is clear now. So this is the range. Now what next? We have to multiply this 2x cube, right? So multiply 2x cube, the polynomial part, both the sides. 2x cube multiplied by 0 less than or equal to 2x cube by x squared plus 1 less than or equal to 2x cube. Now we have 2x cube here, here and over here. Now let's solve it. Here it will be 0 less than or equal to 2x cube by x squared plus 1 less than or equal to 2x cube itself. Here it was multiplied by 1. It will be the same thing. Now take the limits. Limit for the left side as x tends to 0 for 0. Oh, I forgot to write the formula. Let's take f of x less than or equal to this particular question, that is 2x cube by, that's the given, okay? Just write this given all the time. You can write h of x because we were using h of x, or g of x, anything, doesn't matter. So this is the given formula. This question is greater than or equal to f of x and less than or equal to h of x. What is this f of x and h of x? The range 0 and 1. And then we solve it, okay? This is just like a formality. But even if you write from here, you should get marks, okay? But just write it because this is technically a part. Because in the answer key, if that is printed and if the teacher is correcting it and if you're missing, there might be chances that you might lose a mark. So please try to write this as well, okay? Now here, limit as x tends to 0. What's going to happen? It's 0. Limit as x tends to 0 for 2x cube. What happens? Again, it's 0 itself. So even positive negative will be 0 itself. Now this is equal to 0 then. Therefore, from squeeze theorem, what's happening? This is proved, okay? Now you have to write one more statement. Let me just write it. After this, from squeeze theorem, Since we have written all this, it's understood over here. Limit as x tends to 0 for 2x cubed by x squared plus 1 will be equal to 0, because the limits over here tend to 0. And that's the answer, you can see. And you can see over here they have taken x squared by x squared plus 1. Doesn't matter. Why? Because this is also a rational function. It will be within 0 and 1. Okay, the range does not change. Then they have taken modulus over here. Why? Because they're multiplying. Okay, why is this done like this? The answer, whatever you wrote over here is correct itself, but I'll tell you why over here they have done like this. See, x square, what happens? Because x square is there, we are taking x square over here also. Doesn't matter what, it will be a positive number. Don't you agree? Take anything, negative or positive, will be positive. But this one, x, can be negative or positive. Because x domain, the range is 0 to 1, but the domain is all possible real numbers, right? So it can be minus or plus. So here, they have multiplied 2x and 2x. Why? Because initially they have considered this over here and then multiplied x. It's fine, you will get the same answer, but it's just that they have taken the x square already initially, because that's a part of rational function, and then they multiplied the x, and the modulus denotes it can be positive or negative over here, positive or negative, because the square only positive part. That's how we can do it. And then now we come to the limits part. This is very simple, very easy. If it was in the calculator, you can directly put it and do it. But now, since we have to solve it, let's try to write the steps down and then solve it up. I hope you recall the few formulas which we had regarding the infinity. So the most important formula is 1 by x. When the limit of x is infinity, what happens? You can try it in calculator. Divide 1 by a very, very huge number. It's almost 0. But we just take it as 0. Limit is always 0 for 1 by x. So here, looking at this problem, I know the answer is 1 by 3. Just by looking. Why? Because the highest degree over here is x power 2. Here also x power 2. So see the coefficient. It's 1 by 3. That's it. Now, if you're very bold enough, you can do this. The highest coefficients, highest degree, okay, highest degree, both sides, both numerator and denominator is x power 2. That's 2. Degree is 2. Okay, degree is 2. Therefore, x square by 3x square tends to 1 by 3. This is the answer. There is some rule or some formula. It's done in the lessons in the first lesson. I think so. I've talked about this. It'll just be the leading coefficients of the highest degrees. That's the answer. Technically, when we correct the papers, doesn't matter which method you do, as long as you have done a written method and it's a proper method, you should get answer. This must give you the correct answer, but since it's just 2 lines, I would prefer you not to do this. What is the actual method? It's basically see what's the highest degree, divide throughout that by that same number. Here, the highest degree is what? X square. So divide this by x square, even over here divided by x square. And what happens now? Here it will be x squared by x square plus 3x by x square minus 2 by x square. The whole thing divided by this denominator term, 3x squared by x squared plus 4x by x square minus 1 by x square. Now then, let's simplify. What happens when you simplify? X square cancels. You're remaining with the leading 1 over here. And this x and square cancels. You're remaining with plus 3 by x minus 2 by x square. Divided by this is 3. Here the x cancels with this. Plus 4 by x minus 1 by x square. Now we apply the rule limit. Let's apply the limit as it goes to infinity. As tends to, this was a simplification. You can write the limit, doesn't matter, but you're just simplifying it. X tends to infinity is equal to here, even over here. Limit as x tends to infinity. Now limit as x tends to infinity for 1 by x or x squared is equal to 0. Therefore, over here, apply the limit. What happens? You will remain with 1 by 3 and it will be plus limit x tends to, this is a constant so it doesn't matter. Okay, this is going to be too long. You're just writing limit over here, but instead of that directly you can write this, right? You can just directly apply infinity instead of x. It'll be 3 by infinity minus 2 by infinity the whole square divided by, sorry, it's 1 over here. I've written 1 by 3 directly. It's 1. Let's write the numerator separately. Plus 4 by infinity minus 1 by infinity the whole square. That is equal to, this becomes 0. 1 plus 0 minus 0 divided by 3 plus 0 minus 0. It's a 1 by 3. Look, I would never do all these steps in detail. It's understood from here only. I would jump over here and directly do it. But since it's writing, it's better to do this step 1. Sorry, this is 1. This will be 2, 3, 4, 5, and lastly the answer is 6, and you will get full marks. It's very simple. The same method is going on for all the other problems. You can just do them by yourselves, but it's just that it's just, writing. That's what it is. And over here also they have done, see, they have done a bit shorter method, I guess. See over here, just follow this method also. But what I did is also the same thing in detailed writing. You can pause the video now and see this is very simple as well. Whatever is the highest degree, just divide. Over here also, just divide by x squared throughout. You will be remaining with the leading coefficients of the highest degree, and over here everywhere the x will be in the denominator. That means you're dividing everything by infinity. When you're dividing everything by infinity, it will be 0. Gone. These all terms are gone. Only remaining is 1/3. Just by looking at this term, you can tell it's 1/3, or even at the question only. Even you can check your answer. Let's check our answers by using the calculator now. Let's just put this in the equation calculator over here. It's alpha x squared plus 3 alpha x minus 2 divided by 3 alpha x squared plus 4 alpha x minus 1 calc. And what is the infinity value? It is a huge number, so I'll just type some 999s. What's the answer? 1/3 or 0.3333. So 1 divided by 3 is always 0.333. That's it. Just to check your answer, you can use the calculator. Here, answer is 2 by 4 or 1 by 2 or 0.5, half it is. So let's look into the answers here. See, they have done all this. Okay, they have done directly also, but if you understand it, then just do the extra steps as well. It doesn't matter. Now let's look into this particular problem. This one is pretty straightforward. We have just done it a while ago, same way. But here we are minus infinity. And your square root as well. There are various ways to do this problem. Now, which one? I will tell you the easy method, but let me just tell you a few things. Look at the square root. What is that? Let's forget the constant term for a while. Let's just take x squared. This is equal to plus or minus x, isn't it? Basically like modulus x, absolute value x. Absolute value in this sense, what happens? There are two cases, two conditions like a piecewise equation. It will be positive x when x value is greater than or equal to 0, and it will be minus x when x value is less than 0. Is that okay? And now when we solve this, when we take it out, we can see it will be minus, it's, what is the x value? It's minus infinity, sorry. And since it's minus x, so it is x less than 0. That's the thing. But I will do another method because we need to simplify this as well. And that concept, about the minus x, I'll tell you in a while. Let's just simplify this. Minus x remains over here, square root. I need this to be dissolved because I need everything divided by x squared, right? So I have to divide, because this is x squared, I have to just divide by x squared. But can you just divide? If I have to divide over here, I have to divide everywhere, right? Instead of that, Let me divide both the sides, and outside let me multiply it. How about that? If you're thinking how this happens, see, it's basically just the square root. Focus on the square root. Divide by x squared divided by x squared. What is that? It's 1. I did not make any difference. And 4 plus x squared is already there. Now the denominator part, I take it inside. So what happens? X squared into 4 by x squared, distributive property, x squared by x squared, isn't it? So that's why I've written like this. Because I need to get this dissolved, and the x must be divided by, right, for infinity. Therefore, 4 by x squared plus x squared by x squared. And this is in division, so multiplication also must be done. This balanced now. Now, when we simplify this, what's going to happen? Minus x divided by root of x squared of what is this? It'll be 4 by x squared plus 1, isn't it? Now here, take this x squared outside. What happens? It's plus or minus x square root outside the square root. This root square cancels with this root, and outside will be only plus or minus x. And what is remaining? 4 by x squared plus 1. Now, what do we consider? Plus or minus? Look at this. It's minus infinity, so it's the negative part of the x. Therefore, it's minus x. Now, cancel this and this. What is remaining? 1 by square root 4 by x squared plus 1. Now apply the limit. We have to write limit everywhere, okay, like this. Limit as x tends to infinity, minus infinity. The same thing must be over here, and over here. X tends to minus infinity. Now when we apply minus infinity, what happens? 4 by, doesn't matter positive or infinity, square is there, so it is just infinity. Let's write it minus infinity square. It will be positive only, okay? So it will be 1 divided by square root of 1 plus... now this is not 1. Sorry. What is 4 divided by infinity? It's 0 plus 1. That is 1 by square root 1. That is 1. Answer is 1. The answer should be 1. Let's just check answers. Yes, it is 1. 1 by root 1. Or you can just do it in the calculator to check the answer. You will get the correct answer. Same answer itself. Okay, not to worry. So that's the thing. Let's do it in the calculator and check as well. Now here they have not done so many steps. They have directly done it. But the concept is same. See, here they have taken this x square out and they have rearranged it. They have not done all the steps. But why did this minus x come? Sorry. The minus x is because over here it's minus infinity. Okay, let's do this in calculator. Here, let me try this. Just put this terms as it is, minus alpha x divided by square root 4 plus alpha x square, and calculate. At minus infinity means minus a huge number. Answer is 1. If it was positive infinity, it will be a huge number only. It will be minus 1. Look, minus sign is there. So remember, if you are taken only positive x, the answer will be wrong. You will get minus 1, which is not correct. It should be minus x outside, minus minus cancels, and you will get positive answer. This one is simple, straightforward. Over here, since this x dominates, see, whatever happens, the degree is more, right? What will happen when the degree is more? Divide over here both by x square, over here by x cube. Ultimately, you will have 1 by x. Okay? So it will be, just say the degree over here. So ultimately, whatever happens, you will get 1 by x. So 1 by x is equal to 0. So that is the answer. It's 0. You can do the steps. We have done it earlier as well. Similar concepts. Please do go through these problems by yourselves. Oh, now we're here for the natural logarithm, trigonometry logarithm part. You can see that, see, x times sine x is there. What will happen if you apply the limit? Whatever this number, it will be, that same thing will happen, because if you apply 0 over here, because I can see over here it's ln x. So if you apply 0, it's going to be 0. Okay, so what happens is this entire thing dissolves to whatever is the x value. So we're writing L as x. So now if you know the natural logarithm graph, how does it look? It's something like this. It goes to infinity and something. It should not go to the left side. Sorry, there is no ln less than 0 or even equal to 0. Okay, you can't have this. So what happens is it is undefined at 0 somewhere over here. It goes towards infinity from the right side of 0. See, this is very important, that's mentioned plus. Okay, so why? Because it's minus infinity, it's downwards. Even if you know the graph, you can directly check your answers. So this is it. And over here, you can just apply the infinity. And we have done the similar thing before. Here, what happens? It'll just see now. This is here. If you just look at the degree, which is the highest degree, x squared. So this is x. So no matter what, there will be x remaining. Just look at the highest degrees, x squared by x, so it is x. So ultimately this will be as x. Even if you do the rules, ultimately you should know it will be x. Divide everything, and what happens when you apply infinity? This is 0 0, this 1 remains. 1 by 1 by x, what happens? This goes up. It is equal to x by 1, or x. That's the thing. So that's how we get these answers. They are very simple. Please do try solving them by yourselves. The methods are there. Then most probably you'll be asked squeeze theorem, because these are not worthy for big question, or maybe you'll have different parts. A small, this one is a small answer. You can directly do in 2 steps and then solve it up. All these were done even before, so please make sure you go through these, recall your memory. All the methods are there. Here for the cot inverse part, let's look at this one. What exactly is this cot inverse? They are telling cot inverse x as infinity. So cot inverse infinity means this is some angle x. Imagine some angle, sorry, not x, a. Okay. Infinity is equal to cot of a. So we are basically looking for an angle, because I'm taking cot on both the sides, I'm getting this, right? An angle. Which angle does the answer become infinity? At what angle A is the cot graph infinity? You should know the cot graph, cotangent. It is something like this. I mean, they go like this always. And I know that it is undefined at 0. How we can find it's undefined at 0? Cot is inverse of tan, right? Let's take out our calculators. Here, all you need to do is, I know I need to find a point where this is undefined. So cot and tan is inverse of each other. When is tan 0? At tan 0, it's 0 basically. So if I do cot 0 over here, that is 1 by tan 0. This is an undefined. Okay, math error. So basically I can tell the angle must be 0 over here. See, this is not given. It will be like this. Now I'm assuming a value equal to a, an angle. So then if I take this this side, I know I need to find an angle when cot is undefined. But if you remember the cot graph, it is at 0, you will have undefined. The starting at 0 only. Yeah, it's undefined. So that's basically the answer. You can just check the cot graph. The answer is 0. Same way, please do try the other problems. If it's an inverse reciprocal function, just remember this is inverse of 1 by cos. It's basically use 1 by cos and you'll get it. Same way, the methods are there. They are simple and straightforward. Try to, understand, apply by yourselves and check for the answers over here. And here as well. Similarly, you can solve these problems as well. Do it and then check the answers. You can even check your answers by using the calculator method. Directly substitute. All the limits can be substituted. For infinity or minus infinity, use the appropriate number. For infinity, a huge number, 9999. Minus infinity, negative 999. Same way over here. The steps are there. These are very direct ones because there's no much steps in this. Very straightforward ones. But try to write it out, make any substitution steps, and then also you can even just substitute, do the substitution steps or divide it by this power, this term. Just simple steps. In this problem, we have been given this equation and we have been told to multiply and divide by the conjugate expression and simplify. So basically, conjugate is something that is of opposite sign. You can see the sign differs over here. The first term and the second term is same. We have to just multiply and divide and then simplify. Let's just do that. So it's square root 4x squared minus 2x plus 1 minus 2x. When you multiply and divide by this term, that is square root 4x squared minus 2x plus 1 plus 2x, by the same thing here also, minus 2x plus 1 plus 2x. Here what happens is this is basically balanced. If you cancel these both, it's 1, so you're not doing anything wrong. But here I just realized that I've written the square root a bit incorrectly. The square root is only for the first part, not the second part. Here I can use the sum of squares of difference, in the sense x plus a, x minus b, x minus a, sorry. The formula is given as x squared minus a squared. I can apply that formula here. So the first term gets squared. That means square and square root cancel. So it will be 4x squared minus 2x plus 1. And then minus the second term. What happens this term? This also gets squared. That will be 2x the whole square, that is 4x squared. Okay, I'm just writing it directly because it's x plus a, x minus a. I'll just denote it. See over here, x minus a, we have first x plus a. So this is the formula. It will be x squared, the first term square, minus the second term square is 4x squared. So I will have to write minus 4x squared. Now this and this cancels and the denominator remains same. Over here we have 4x squared minus 2x plus 1, and outside the square root we have plus 2x. Now you need to just remove the x, so divide throughout by x, and then you can easily simplify it. Now it's again same step, I think. So let's just check the steps over here. It's the same. Yeah, it's already done the same thing. So I'll just show you over here. Now the first part is not done, only this part is not done. Remember, write this term, multiply and divide by this. They have told in the hint, right? Multiply and divide by the conjugate. And then what you basically do over here is use the identity. This is a difference of squares. A square minus b square. Over here we have x plus ax minus b will be x square minus a square. So the first term squared, this we got, minus the second term squared, we got this. The 4x square and cancels, and you're remaining with, see over here, what is remaining? This term. I'll just remove that. Minus 2x plus 1 divided by root of 4x squared minus 2x plus 1 plus 2x. Now we know how we simplify. Technically, when we have this infinity, we don't keep it as multiple, we divide it, because 1 divided by infinity is 0, right? So remove this x. The highest degree is x, so remove throughout both the sides. What happens? It'll be minus 2 plus 1 by x. Over here the x is gone. Here when you multiply this x inside the square root, it becomes x square. Look, you're multiplying this x inside the square root. See why? Because if it's inside the square root, when we take it out, it becomes only 1. But now when you multiply it inside, say x is multiplied inside, it should be x squared. Okay, because you have a square root outside to balance it off. So that's why it became, when you multiply this x inside, it will be divided by 1 by x squared. Okay, so this basically over here, if you just look here, this x is multiplied. So in the square root, what happens is 4x squared divided by x squared minus 2x by x squared plus 1 by x squared. And therefore you are remaining with 1 plus x squared minus 2. These are the things. Now just apply the infinity everywhere. All this becomes 0, 0, 0, whatever is having divided by x. The remaining terms are minus 2, square root of 4, all the others are 0, plus 2. So it will be minus 2 divided by 2 plus 2, that is minus 2 by 4, or negative half. Minus. So that's the answer. This is very simple. It's just algebraic substitution and solving. Here also it's the same thing. Please multiply and divide by the conjugate. Use the rule. I'll write it again. You can even consider it to be a plus b, a minus b. That is a square minus b square. So please use this rule and then easily simplify it. Whatever is having divided by x, when you apply infinity, it becomes 0, 0, everywhere 0. Even if it's minus infinity also, it becomes 0. So that is the answer, and that's the end. It's been a long question number 16, because there are various types. Please do focus more on squeeze theorem. Most probably that will be coming. because that is a very important one. It's a very simple one as well. So please do focus on that. And the limits, you can do it and check the answers and calculate as well. We are now in the question number 17. This is a two-part question. The first part is to find the derivative of a function at a given point. It's very simple. The second part, that is to graph, the derivatives. Now, they will ask you either to graph the derivative, or the derivative will be given and we have to graph the function. We'll look into all the type of problems here. The first one, which is, see now, one more thing I want to tell you. When we go for corrections, they will specify us, it doesn't matter which method is used, as long it is in writing and in proper method, and you're getting the exact answer, you will get the full marks itself. So now over here, in the solution set, they have specified to use this formula and solve. You might know this derivative formula, and then we use it, and then we simplify and finally find the answer. This is possible, but even if you use the power rule, you should technically get the full marks. But I will do both the methods. I think so over here they have used this formula, but there's one more formula. Let me just check. Yeah, this one, the slope formula. We will look into all these in a while. Now let's use this method and then solve. What does this method specify exactly? Now, you might know what is exactly slope. I mean, the derivative. Derivative is the slope of the tangent line. How do we find slope? Imagine this is the curve. We need to find the slope from here to here. We need at least 2 points, x1, y1, x2, y2. Is it possible to find only at x1, only at one particular point like this, only at this point? Is it possible? No. But I can do one thing. Instead of taking the point so far away, I will take it very, very near. Okay. This is x1, y1. This distance, the next point is x1 plus h. Very close. Now what we do is we will get 2 points. We can substitute away and solve. And then we are taking the limit of this h to 0. That means this point is infinitesimally close to this particular point. It's basically almost that same point. Okay, so close. That is the concept behind this formula. Now this is the main details of it. Now if you just see this formula, direct substitution and then solving it, basically nothing much over here. Now how do you do this is, say, okay, we need to first, we have f of x given. Okay, f of x is there, equals 3x cubed plus 2x minus 1. What is f of x plus h? Here, wherever x is, they put plus h. That's it. 3, it becomes x plus h the whole cube, plus 2 into x plus h minus 1. Okay, it will be minus 1. This is the x of h. H remains as it is. We will take the limit of 0. It will be dissolved. So now here, let's do the substitutions. The limit as h tends to 0. What is f of x plus h? Let's try to be more straight. Okay. It's 3 of x plus h the whole cube plus 2 of x plus h minus 1 minus, what is f of x? 3x cubed plus 2x minus 1 divided by h. Now, I will be really honest with you. I did this just a while ago. I have deleted that part. Why? Because I forgot to multiply this minus sign throughout. I did everything right, but this minus, I just multiplied for 3x cubed because I had not used this brackets. I was just writing it and I forgot to minus. I multiplied the minus and it went all wrong. So please be careful. The signs are very important. If you miss the sign, then you will get wrong answer. Now here we can't directly solve it. You need to use the identity, that is a plus b the whole cube. I hope you remember that's a cube plus b cube plus 3a squared b plus 3ab squared. Okay, and then now we just do the substitution again. Limit h tends to 0. 3 multiplied by what? Ax plus h the whole cube will be x cube plus h cube plus 3x square h plus 3xh square plus This multiplied inside will be 2x plus 2h minus 1 minus 3x cubed minus 2x plus 1. It's direct substitution, algebraic substitutions, divided by h. Now again you have to multiply this 3. So we will do that in step itself. Limit as h tends to 0. It'll be 3x cubed plus 3h cubed plus 9x squared h plus 3x, oh sorry, it's 9 over here, okay? 9xh squared plus 2x plus 2h minus 1 minus 3x cubed minus 2x plus 1. Then divide this by h. Now we can see some terms get cancelled. That's 3x cubed minus 2x and 2x plus 1 minus 1. What else? Let's write the remaining terms. It is limit as h tends to 0. What is remaining? It's 3h cubed plus 9x squared h plus 9xh squared plus 2h 2h plus 1 divided by h. Sorry, what am I writing? There's no plus 1. My bad. Now, this is the thing. Now here, what you need to do is divide h throughout. It will be limit as h tends to 0. That will be 3h cubed divided by h is 3h squared. I'm writing it directly. Plus 9x squared, h and h cancels. Plus 9xh because h squared and h cancels. Plus 2h cancels. Now apply the limit. What happens when you apply the limit? This will be 3 times 0 plus 9x squared plus 9x of 0 plus 2. This technically will be, this is the substitution over here. Sorry, this is 2. And now all the, wherever the h is there, they become 0. So you can directly write whatever is non-h part. That is 9x squared plus 2. That's it. This is the derivative. We did all this formula just to get this answer. Now I will tell you how you can directly get this as well by power rule. We know this 3 comes down, isn't it? So we have over here, let's derive f dash of x will be equal to 3 comes down will be 9x, 3 minus 1 is 2 plus 2, the constant is 0. The same answer. But this is the actual formula to get the derivative. This is the power rule, the derivation, the simpler versions. Now over here, if you want to find x1, see this also can be done. Now x1, what happens? Just substitute 1 over here. I'll write it over here. 9 into 1 the whole square plus 2. If it's 2, 9 into 2 the whole square plus 2. And lastly 3, 9 into 3 the whole square plus 2. So it's just substitute the values, and in the calculator you can do it. 1 square is 1, 9 plus 2 is 11, 4 times 9 is 36, 36 plus 2 is 38, 9 square 9, 9 is 81, 81 plus 2 is 83. So these will be the final answer, 11, 38 and 83. So let's just check the answer. It's 11, 38 and 83. That's how we solve it. Over here the detailed method is also there. You can just refer to this. So this is the actual method of deriving. This is without the power rule, by directly the formula. There are more problems on this. Please do solve them by yourselves. These are simple problems. Here you can see now, if you're directly deriving it, what's going to be the answer? It's just 3. Answer is 3. Doesn't matter what 3. Why? 3 into x will be only 3. But here both the formulas are used. That is the first one. Now here they have taken f of 1. I'll write the formula first. 1 second. The formula is, for this part we just did, limit as h tends to 0. It is f of whatever is this a or x. I'll write it as a because it's given as a plus h minus f of a divided by h. Here it is basically f of b minus f of a divided by b minus a. But now a value is 1, so they have substituted 1 and then solved it up. Okay, just like what we have done a while ago, direct substitution. Now, if the value is not of cube or squared, it's much simpler. You can see easily, you can get the answer. Doesn't matter which formula you're using. They're using 2.1 formula and 2.2. This is first formula, second formula. You will get the same answer. They are same. Both are derivative because you're finding the slope of the derivative, right? Slope of the tangent line. That's the derivative basically. Even over here, it's the same concept. First formula, second formula, you'll get the answer. The steps are there. Please refer to the steps as well. And now, if you're thinking of the power rule, this 2 comes down, it'll be 2 times 3 is 6x. That's the answer. Now, what is the a value? It's 1. So 6x is 6 times 1, that's 6. Here, you can do the same thing. It'll be long, but if you're doing the power rule, I will just do it. Then you can refer the formula methods. The power rule over here, we know root x derivative is 1 by 2 root x. So I'll directly apply that. 1 by 2 root of 3x plus 1 multiplied by the chain rule. The derivative of this will be 3. So it is 3 by 2 root 3x plus 1. Now substitute this 1 over here. It will be 3 by 2 root of 3 into 1 plus 1. That is equal to 3 by 2 root of 3 plus 1. That is 3 by 2 root of 4. That's 2 itself. 3 by 2 times 2. It's 3/4 or 0.75. So that's how we solve it. It's 3/4 answer. Both the cases will be 3/4. Even if you do in calculator, I'll just remind you how to do in calculator. All you need to do is press shift and this symbol over here, and now type the equation as it is. 3 alpha x plus 1. What is the x value given? That's the a value over here. It's mentioned as 1. The answer is 0.75 or 34. But you can't do the calculator method for this. It's a writing. So please do any of the writing method, this, or even the power rule. See what I've just done. The same thing, and get the answer in steps. Please do follow the same rule everywhere. Over here, you can take this to the power up. It'll be x plus 1 the whole power minus 1, and then use the power rule, or you can use the formula over here and get it. A value is 2, so therefore they have changed the formula. Say it's a. This is the actual formula which I've written over here in the top two. So that this is the formulas you have to refer. Please do write the formulas. It's not mentioned here. It's very important to write these formulas and then start solving. Using 2.1, that is this formula over here. And if you're thinking of power rule, it's very simple. 6x, that's it. Now they are not given the a value. That means you have to use this x as it is and keep it in terms of x itself. So just do the power rule, it will be 6x. Yes. Here also 2x plus minus 2, sorry, 2x minus 2. And here it will be 3x plus 2, it will be 4x cube, 3x squared plus 2, it will be 4x cube minus 2a minus 4x, and so on. Please do try them by yourselves and then check for the answers. If you're doing the derivative method, take this power up, it will be x plus 1 whole power minus 1, and then solve it up. Same thing here, square root we know 1 by 2 root x. So here, and then the chain rule. Don't forget the chain rule as well. Now we go to the last part of this particular question, that is to sketch the graph of the derivatives. Now over here, let's see what they have asked. It is to use the graph of f to sketch graph f dash. F dash means we need to find the derivative. Always remember, let's try understanding by equation. What is this graph? It is a quadratic graph, right? Now when I derive quadratic graph, it will be 2x. So the answer must be a linear graph. Is it true? Yes, it's linear. Now what is this graph? This is a cubic graph, right? X cube. The answer when I derive it will be 3x squared. Just see the function over here. It should be a quadratic. It must be a quadratic graph, a parabola. That's true. Just let's go to the other ones also. This is to the power 4, I believe, because there's jumps, right? X to the power 4. So this answer will be x to the power 3. That is cubic. Say it's a cubic over here. This is a flat line, linear. So the answer will be a constant. Now imagine if you have, say, x. What is the answer? Or 2x. The answer will be 2 or a constant. Okay, 1 like that. So the answer will be a constant. Here this graph is of 2x, so that's why it's a constant. Now similarly, yeah, the same thing, derivatives only. We will come to this also in a while. We will see all these. Now let's go back and see how to derive this graph. So we know the answer will be like this. But how do you exactly do that? Because you won't have any options. You can't guess and select it. Which will be the correct graph? Now you won't draw the exact graph. You have to just draw a sketch. If you look carefully over here, you can see a pattern. Wherever the graph is increasing and decreasing, there's a difference here. Let's see this first part, it's decreasing, right? Let's see till where it is decreasing. Here it decreases till this point, till this. So this is an important point. Now where is that? 0. So see, till 0, mark something, mark a point. Okay, you will have like this, mark 0. Wherever it is decreasing, the part of the graph only will be before this, before. Where it's increasing, it will be over this. That's the concept. Now here, this is a parabola. You should know by looking at it, the derivative will be a linear function and will just be like this, like this. Now, whereas let's look at the next one. This has difference over here, it increases over here, that is plus, minus, plus. Okay, what are the points? It's close to 0. Here it's not mentioned, but here they have mentioned it to be how much? 0.5. Okay, this must be given in the question, but if it's not given, just take some distance away. So this much distance, mark that point, and this is another decrease to increase. Wherever it changes from increasing to decreasing or decreasing to increase, mark that point. This left side is plus, so what happens? It will be increasing. Sorry, it will be not increasing. Here it will be above the x-axis. That's it. Here it was below if it's decreasing, above if it's increasing. Now wherever it's decreasing, it will just be below. Okay, below. But let's do the increasing first. Here let's do the increasing first. So this and this point, right? Both sides, this is increasing, that much it must be above, this also must be above. Then it's decreasing. See, this is above, this is above. So these must connect like this, right, in the below. That's it. And we know this is a cubic, so the answer will be a parabola. That's how we can graph it easily. And the next one over here, again, let's look into where it's changed and increasing, decreasing till here, increasing here, decreasing here, increasing. So in the graph, what happens? We have to mark these 3 points. 1, 2, 3. It's decreasing, so it will be below, something like this. Last one, it's increasing, so it will be above. But what about this middle part? Here it's increasing, so it will be like this, but it has to come and touch here, because here again it's decreasing. See, this is plus, minus, minus, plus, minus, plus. If there is change in that plus minus, then it should come and touch over here. If it was no change, then it's fine. It would have gone something like this. Okay, if this was that, it would have gone. But anyways, now this is again minus, that means in the below, this will be the answer, something like that. It won't be accurate, but you can see this is the answer. These are accurate because they have just known accurately, they have put the derived equation and found the graph. But that's something. Now the last one over here will be a flat line. So why a flat line? Looking at this, you must understand it's a linear function. Okay, try to guess. This is x, but now the x will be 45 degrees. The slope is a little bit more, so you can see for every one distance of x, there will be at least 2 distance of y. So it's 2 by 1, that is 2. So it's 2x. The derivative of 2x is 2. So therefore the line is at 2. And now if you're thinking about increasing, decreasing, what's happening? It's only increasing. What do you do then? There is no point where it will change up and down. It's only increasing. So it must be any answer in the above part. This is only increasing, so it must be anything above the x-axis, here, anywhere. Okay. Now, if there is no value, it's just like this. Even if you put a line over here, yes, that's correct at x. Sorry, at 1, like this. This is also correct because they have not mentioned anything. You can tell this is correct and this is correct. But if it was like this, then it should be anything down. Okay, line at the down, a straight line. And then over here again we need to find the derivative graph itself. I thought there was two types of problem, that is derivative graph and the function. Here only derivative, so whatever I just now told you, if you remember that, it's enough. Now let's look over here. What's happening? This one here, let's look at this. It's decreasing and decreasing. So these, you can see, will be below the axis itself. Now this one is very hard to graph, to be very honest, but let's look at each part of the graph. It's decreasing, decreasing here, decreasing, decreasing. All points are decreasing, so everything must be below the graph only. So there is like a thumb rule in such cases. So this, just do it like that. Whereas this one, it's decreasing, so it can't be above, just make it below. And this part is decreasing, just let it be over here. Whereas this part, instead of increasing, you have to just make it down. So this is it. Okay, just main concept is all these part of the graphs will be below when you derive it. That is the main part. Here now, this is a simple one. What if it's a constant? Now imagine this is a constant at 2, I guess. So what is the derivative of 2? 0. So there is no graph over here. Can you see that? There is no graph anywhere up or below. It is at 0 only. Can you see that? Why? Because it is derivative of any constant is 0. Doesn't matter what, it will be only at 0. Now till this point, make a hole because it's a hole. Now what about the next point? Here there's one more thing which you must remember. Whenever you derive anything, even if it's a point or a hole, we generally take it as a whole itself. So that is one thing. Now the derivative of this, again, it's a linear function. It will be a constant, right? But it's what, increasing, so it is up. And it's like a 45-degree line. Its equation is x, so its derivative is 1. So at 1, okay, till here. This is a piecewise. Now this is again a parabola, but it's what? It's decreasing. So now, sorry, it's not decreasing. Till over here it's increasing. This is plus, from here it's minus. So this point is said to be 1. The part is up and the remaining part is down. Because we know parabola's x squared, the derivative will be linear function 2x. It's a linear function. So it must be a straight line. But till this point, left side will be above, this will be below. That's the concept. That's how we graph these. And now again, same way, please do try them by yourselves and then check for the answers. Here also the same thing, what I told, decreasing, decreasing. So it'll be down. Here it's two linear functions, it'll be just two straight lines. But look at this. This is what? Increasing, decreasing. So this part is above, this part is below. I hope that is clear. Now look at this problem. Here I thought all the derivatives, sorry, there is a function also. Now here the derivative is given and you need to find the continuous function. What we did just a while ago, see in the previous problem, we were finding derivative, right? What we did now, we have to do opposite. Wherever the graph is above this x-axis, that means it increases. Wherever it's below, it decreases. Okay, now this is the concept, and this part over here, y-intercept, is also important. Why? Because have you noticed y-intercept, wherever this point is there, where it touches, here it also touches. So there's some similarities we will see now in this problem. Here, this is the derivative. Maybe this is a cubic graph. When we find the original graph, it will be one more, in the sense, sorry for that, in the sense, now if this is cubic, we should have the original graph to be x power 4, because only when we derive x to the power 4 we will get x to the power 3, right? So the original function must be x to the power 4. That means it's like a parabola with undulations. So how do we do that? Let's look at the graph, it will be easier to understand. Here, this part is okay at 0, that's fine. But now, what is above the graph? Above. This part, this much is above the graph, right? Till here, it will be increasing. See this point, wherever this point. Again, I will remind you, you won't get accurate answers. It's just approximate. See till this point, that's over here. It's always increasing. See, it's increasing, going up, up, up. Now, which part is below? All this part till over here is below, right? So till that part, see till over here, it decreases because it's all below. Down, minus, plus. See, this is above. Above I'll write A, below I'll write B. A is all positive, B is negative. See, wait a minute. See, yeah, from here. Above the x-axis is all increasing, that's plus. From here, this is the, it should match, but you know, it's not so accurate. But from here, it's going down. And over here, you stop. Again, it's above from here to here. So what happens? Where is that point exactly? From here to here, it again is increasing. Can you see that? It goes up. Then the last point is again below, right? All this is going down. So that's it. Now you don't need to do it very accurately because it's not possible to do accuracy like this. Just see where it's above and below. Those points, just mark it up. Okay. And then since this is a quadratic, I know cubic, then this will be x to the power 4. It's a even power graph. It will be a parabola, something like this. Now I know over here. See, then since it touches over here, I can come down till over here and then stay over here. Then little up till over here. Sorry, it should be like this. Up over here, positive, then down. Okay, it won't be accurate, but they just want you to know where are the graphs. So these are the important points, the touching points. See, these must be accurately plotted, and then remaining, it's fine, you know, if it's not very accurate. The same concept is used over here, so please make sure you graph them properly. Even over here, you can see, just make sure whatever is above the x-axis, if it's above, it increases. Till this point, what happens? It increases. Sorry, this is not this. This point and the turning point matters. See, whenever you see a point where it touches the axis, here, this is the turning point. Okay, now I recall, this is again turning point. This is the turning point. Now, what about this point? The one which is turning point here, that is basically the point 0 over here. Okay. And now remember what is going down, right? Whatever is going down, sorry, above the axis. See, I'm also getting confused. A will be increasing, B will be all decreasing, minus and minus, because till over here it's all below. And again, A, it will be increasing. So make sure you understand this. Just try to get the grasp of it. And over here, again, you can try this, see the concepts, see where it is increasing, changing, and then you can accordingly graph it out. So that's how we basically do the graphs. Graphing is simple as long as you understand few key points, what happens where. So please make sure you understand this thoroughly and try practicing more problems and solve these problems by yourselves. It'll be much easier then. Question number 18 is to solve real life problems. It is on using derivatives of exponential and logarithmic functions. These are comparatively simpler and easy compared to the other writing part. Here, let's look into the problem. This graph, I'm not sure whether it will be given. Even if it's not given, you can understand the graph from this equation. So this is the question. The concentration C of a certain chemical after t seconds of an autocatalytic reaction is given by C of t, concentration with respect to time, equals 10 by 9 e to the power minus 20 t plus 1. Show that C dash of t, that's derivative of t, is always greater than 0, and use this information to determine the concentration of the chemical never exceeds 10. Now this is, you have to solve it, but then there is a lot of understanding as well over here. First of all, here don't be confused. They have told C dash of t is greater than 0, fine. But the concentration of the chemical never exceeds 10 means this is the given equation. You can do this first and this second, but I will do this one first because we have to use the given equation itself, right? What does this mean? Determine that the concentration, this concentration of this chemical never exceeds 10. That means, doesn't matter what, this will be maximum, 10 will be maximum. If you have the graph, yes, you can point it out over here. But what if you don't have the graph? That means you need to increase this time towards infinity and see what will be the concentration value. So this given equation is there, right? Take the limit as x tends to infinity. That is it. 10 divided by 9 e to the power minus 20t plus 1. Now here, when you're writing it, make sure you note it. This is the question. Well, that's a bad line. So this is the question I'm doing, this one, the concentration. Okay, I'll just write the same part over here. Okay, and then I will solve it. Just write it out. Determining the concentration of the chemical never exceeds 10. And then I will start writing this. We will take limit of x tends to infinity. X is basically what, the time over here. Okay, you can take it as t because it's given as t, right? So t is towards infinity, not x. It's same thing. If you change this to x, you can keep this x or just change it to t and t, showing its time. Now let me solve this. You can use your calculator, but over here, how would you simplify this? Now substitute this to be infinity. You can even directly substitute over here. Why? Because e to the power minus 20, rearrange this and write. What happens? 10 divided by 9 divided by e to the power 20t, isn't it? Plus 1. Now let's substitute the limit. It's, sorry, not x, it's t tends to infinity. Now when I do the limit of infinity, I don't write that. Now I'll apply the limit. It becomes 10 divided by 9 divided by e to the power 20 times infinity plus 1. What is anything to the e to the power raised to infinity? It's infinity itself, right? You can try it in the calculator. It'll be a huge number. Don't put a big number, 999. You'll get a math error. Take it, say 9, then 10 or 50, 100. You'll get a huge number. So this basically will be 10 divided by 1 divided by huge number is 0 plus 1. That is 10 divided by 1. What's the answer? 10. So even if you even if you extend towards infinity, this will be less than 10 because it's a limit. It cannot touch this. It's approaching the value 10, but it will never be equal to 10. So this is an asymptote at 10. I mean, you can see that's an asymptote at 10. So this denotes it never exceeds. Because when you took the limit towards infinity, it just showed what? 10. That means this equation, doesn't matter what time you increase, will always be tending towards infinity because there's an asymptote at 10, horizontal asymptote, which tells the concentration can never exceed the level of 10. I hope this is clear. This is the first part. You can do the second or first, it's fine because it's directly given, the equation, that same equation we use. Now for the second part, the derivative. What do you do over here? Just derive this given function. It will be c dash of t, that is equal to, now don't go to do the quotient rule, just bring this power up. It will be negative power. It will be 9 e to the power minus 20t plus 1, the whole power minus 1. That's it. Now then, let's derive it. 10 is a constant. This minus 1 comes over here. It will be minus 1 times 9 e to the power minus 20t plus 1, the whole power negative 2, multiplied with the derivation of this one, e to the power. It will be e to the power minus 20t multiplied with, again, just the derivation of chain rule. Okay, derivation of this is minus 20. So much. Now let's see, let's simplify this. This becomes 10 times 20 is 200. Minus becomes plus, and what's remaining? I'll write this e to the power minus 20t multiplied by 9 e to the power minus 20t plus 1, all minus 2. Now this is negative power, so take it down to be positive power. It's going to be 200 e to the power minus 20t divided by 9 e to the power minus 20t plus 1 the whole squared. Now look at this. What does this tell us? First of all, e to the power anything is always positive. If you know the graph, it's like this, so anything will be positive. So this will be a positive value. 200 is positive. Now here, even if it's negative, it's going to be positive itself. But even if it's negative, square will always make the value positive. So this indicates it's always greater than 0. It can never be 0. Okay? Because you're squaring it up. And over here, even if this part is 0, what happens? Plus 1, it's always going to be 1. Doesn't matter what, because it cannot be negative. Even if it's negative, there will be a value. It will be always exceeding more than 1, even over here. So the denominator can never be undefined. That's the first thing. And over here, because of this plus 1, and it cannot be negative at all. Doesn't matter what, it will be positive. So that's basically it. You can see, okay, what happened over here? Oh, I just realized something. I forgot to multiply 9, but doesn't matter. That's just a 9 over here. See, when I derived this e to the power, I just wrote this. Sorry, I forgot this constant over here, 9. So 9 into 20 into 10, it'll be 200 times 9. That's 1800 over here, which I just forgot. But that doesn't make much difference here. But please make sure you're careful with your answer. See, everything else is correct. Only that 9, which I forgot, and everything else is the same thing. But now looking at that, you can directly say this can never ever be negative. Why? Because now the derivative means it's the slope of the tangent line, right? It's the slope of the tangent line. That means all the time they're having positive slope, so it always increases. That means it's only like the slope. Doesn't matter what, it will be like this, all the slopes. That means the function is always increasing. You can see. That's the thing. I hope this is clear. And the next part, we had done this part already. The answer was 10, so that was not exceeding 10. This is it. It's very easy and simple. Just that you have to do it 2 times. Now here also it's the same thing. If you derive it, what's happening? Here you're getting square and this e to the power. Doesn't matter what, this won't be negative. It's always greater than 0. The same concept. Just derivation is a little bit different. Here it's written down in each step. So make sure you tell that the tangent, the slope of the tangent line is always positive. Therefore, it's always increasing. And the next one, if you just apply, even in your calculator, if you just apply this to t to be infinite, it'll be 6 divided by 0 plus 1. That's 6. Here also you can do the same thing. Now look over here. This will be 0. See, the same concept, no difference at all, but the ultimate answer will be 10 divided by this becomes 0, right? Plus 2. 10 by 2 is 5. So the answer is 5 here. Okay, just please make sure that this is the 0 5 part, because it's 10 by 2. Whereas over here, that's just derivation, what we just now did, and it will be squared in the bottom. Over here it is e to the power. It doesn't matter what, it will be a positive value. So it's always having a positive tangent slope. So that's always increasing and greater than 0, the derivative. That's the end of this topic. It's a very short and simple topic. Just 2 concepts. Finding the limit at the time infinite, whenever the time is tending towards infinity. And one more thing is just deriving the function and finding that the slope is always positive. The question number 19, the penultimate question in the end of term exam questions. It is to find derivatives implicitly. Implicit derivation is when you have 2 terms, 2 variables. Now let's look into it. Here you can see you are to find for y dash of x, where x square y square minus 2x equals 4 minus 4y. You can see x is over here and y is there. So what you need to do is derive it implicitly. That is, just do the derivation. This is a function x. We derive with respect to what over here? When you look over here, you can see it's with respect to x, isn't it? So whenever you have x, it's normal derivation. It will be just 2x. But when you derive with y, you always have to derive it normally and add, y dash, the derivation of y as well. We will do it now. You'll understand it. let's apply the derivation now. You do not need to rearrange this and get all terms at one side because it's direct implicit differentiation. Understand where it's product rule, quotient rule, and chain rule. You can see this is one term, so it's a product rule here. It'll be like u dash v plus uv dash. What will happen over here? It will be 2x, that's the derivation of the first term, into y square plus x square into 2y. See, if it was x, you just derive it as 2y, but now you have to write its derivative also, y dash. You can write y dash of x, or let's just write it as y dash. It's understood because the derivative is with respect to x. Now, why we don't write 2x into x dash? Because the derivative of x dash means dx by dx, that is equal to 1. Only when y implicitly we are doing other variable, that's why we write it like this. Okay, that y dash means it's dy by dx. If it was, this is y dash. If it was x dash, it would mean dx by dx. That's 1. So we don't write it basically. Now then, the first part is over. Minus 2, because x will become 1, equals, what is 4? Derivative of 4 is 0, minus 4. Now, derivative of 4y would be 4. Derivative of 4x is just 4, but 4y is 4 into y dash. Now, what do you want is y dash of x. Now, this y dash means it is y dash of x. Okay, y dash is equal to y dash of x. I'm just not writing because it'll be simpler. Now, let's keep all the y dash at one side. Now, this is positive, so I'll leave it over here. This negative 2x into y square, I'll take it to the other side. Minus 4 times y dash, I'll bring it to the other side. So it'll become x squared. I'll write 2 first, 2x squared y into y dash plus 4y dash. That's derivative of y. And this 2 to the other side will be plus 2. And this will be minus 2xy squared. You are supposed to find y dash. So let's take this common out, this and this. If you remove this common out, what's remaining? Remaining with 2x squared y plus 4, that is equal to 2 minus 2xy squared. Now take this to the other side, it will be y dash equals 2 minus 2xy squared divided by 2x squared y plus 4. This is y dash of x. This is the answer. Now this is the answer. They have told to find the tangent line. This is the implicit derivative. Now substitute the x and y value. X is 2, y is, so y dash will be equal to 2 minus 2 times, what is x value? It's 2, and y is minus 2 the whole square divided by 2 into 2 square into minus 2 plus 4. You can use the calculator over here. It'll be 2 square is 4, 4 2s are 8, 8 2s are 16, so it's 2 minus 16. And again, it's 2 square is 4, 4 2s are 8, 8 2s are 16, but it's negative 16 here. Why? Here the sign dissolves. When you square the negative 2, it will be positive 4. And it's positive, only this sign remains. But here there is minus 2, which will be minus 4. And lastly, we have plus 4. That will be equal to negative 14 divided by minus 12. That is 7 by 6 positive. So this is basically the answer. This is the slope of the tangent line. Now, you know the equation for the tangent line, isn't it? We have done this before. I will just write it over here itself at the side. Now, this is done. That's the first part. I'll change the color now. That's not required to be written. That's for understanding only. This was the product rule thing. Now, over here, we need to write the equation of the tangent line. That is given by y minus y naught equals m into x minus x naught, or you can write a different variation of this, that's fine. Whatever you know, these values will be considered to be x naught, y naught. Now what we do, the y value, just substitute over here, minus y naught is negative 2 equals 7 by 6. We have found this. Y dash is basically the m value, okay? M is equal to y dash into x minus x naught is 2. Now simplify, it will be y plus 2 equals 7 by 6 of x minus 2. So what I'll do is I'll just multiply this outside, the distributive property. What I mean is 7 by 6 is multiplied to x and minus 7 times 2 by 6. Here you will get y plus 2 equals 7 by 6x minus 1 time 3 times, it will be 7 by 3. Let's take this 2 to the other side. It will be y equals 7 by 6x minus 7 thirds plus 2. So if you want to write this, it will be multiply this by 3 on both the sides. This is going to be, you can put in the calculator, but otherwise it will just be plus, multiply 3 and 3, it will be 6 by 3. And now you can do it's negative 1/3. Okay, the answer will be negative 1/3 over here. The final answer would be y equals 7 by 6x minus 1/3. So this is your final equation. This was the slope formula, slope value. That's the answer. If you have written all this, you should get the full marks, and that is what has been asked over here. Now, to find why do we do the implicit derivation? It is to find the slope of the tangent line. Derivative would be slope of the tangent line. Once you have found the slope, just apply in the equation over here, equation of any line. Now, here just the slope is of the tangent line. That means the equation of the tangent line. So that's how we get it. Let's just double check answers. It will be the same methods are done over here, I believe. Let's see the answer. It's 7 by 6. We got the same one. And then finally, okay, now we have done all the simplification, but they have stopped at this step itself. Y plus 2, 7 by 6, x minus 2. So you can stop over there. But it doesn't, if you know the simplification, this is distributive property of multiplying inside and this to the other side, you can do this in calculator, you'll directly get the answers. So it's up to you. You can go till over here, it's fine. Otherwise, they have stopped over here, that's also correct. So this is how we basically do it. The graph is not required. Don't go to, the graph won't be given. This is just for your extra understanding. It's not possible for us to draw the accurate graph of this. So it's just for the understanding. Now here in this problem, they have told us to find explicitly and implicitly. That means we have to do both. What is explicit, by the way? Explicit is, you have to get y at one side and all the other terms at other side. Like for example, this is the equation, right? Let's rearrange this. Y alone, let's keep 4y squared equals 8 minus x squared. Take 4 to the other side. It will be y squared equals 8 minus x squared by 4. You can simplify, the square root. So square root on both the sides would give us square root of 8 minus x squared by 4. Now if you simplify it further, you will get square root 8 minus x squared divided by 2. Okay, this is y alone at one side, and we have all the other terms over here, and we solve it. This is explicit. Okay, this is explicit derivative. Now if it's implicit, what happens is we just apply derivative on both the sides. See, x squared plus 4y squared equals 8. Take the function as it is. You don't need to change. Now you just derive. Now let's do the derivation over here first. What is the derivation of root x? It's 1 by 2 root x, right? So let's take y equals half outside, and it will be 1 by 2 root x, that is 8 minus x squared. But it's not over. There is a chain rule. What is this derivative? It will be minus 2x. The derivative of minus x squared is minus 2x. And we can simplify. See, this half cancels over here. Negative remains. Oh, there is one more half. So it will be y equals, wait, instead of that, what I'll do is, just for easy understanding, I will just cancel this half. So this 2 and 2 is gone. So you're remaining with negative half multiplied by 1 by root of 8 minus x squared. This is the answer. This is now, oh, I forgot to write. It's y dash, y dash. Okay, that's the answer. Now, when we derive over here, it may not be the same thing. Let's do it. It's 2x plus 4 into 2y into y dash equals 0, because derivation of 8 will be 0. Just derive both the sides. Now what happens? Rearrange. Take the 2x to the other side. It will be 4 into 2 is 8. I will write over here 8y into y dash equals minus 2x. Y dash is equal to, take 8y to the other side, minus 2x by 8y. Wasn't this so easy? Now directly you got it. But there is a drawback. Here, can you see any y term at the right side? No, right? Only with x you can easily solve. I mean, obviously you can find y from here, but only x is there in this. But here what happens is, you will have x and y in the right side term. This is implicitly, because you have a term in terms of y also. But now I will show you why they are equal. Let's substitute this x and y and solve the slope. For this, y dash is equal to what? Negative half into 1 divided by 8 minus, what is x value? It's 2 square. The whole square root. You can just put in the calculator to do it, but let's solve it over here. Half into, what happens here is 8 minus 2 square is 4. 4. And when you take this out, what happens? 8 minus 4 square root is 2 over here. Okay, half, negative half into half will be negative 1/4. I just realized that I forgot the x value here. This x value remains up over here. Okay, I'm so sorry for that. I just cancelled 2 and just forgot the x. Over here there is x substitution. The x value is 2 and we will have 2. So here, what's the answer? Negative half. Negative half will be the answer. That's the correct answer. Now what about over here? Here just substitute negative 2 into x value is 2 divided by, you can even simplify this to be 1 by 4. It's up to you. Or y is 1. So this is negative 4 by 8, that is negative half. So you can see the slope, the derivative of the slope, tangent line. The derivative is the slope of the tangent line. That is equal in both the cases. Whether you do implicitly or explicitly, it doesn't matter. The answer will be the same. But you can see for explicit, it's such a long procedure, whereas implicit was so simple. That's why whenever you have two terms like this on both the sides, implicit derivative makes your problems very easy. Okay, now you can see that's the answer, negative half on both the sides. We will move on to the next problem. Here it's the same thing, it's just that you have to use product rule and two places and then solve it up. Please do try solving this. It's basic derivation, that's it, nothing much over here. You can see explicitly this is just applied the derivative and that's all. And then you can do the substitution, right? Because if you do the simplification over here, it'll just take a crazy lot of time. Whereas implicitly you can get a more refined answer. I mean, this is more simplified. You can say there is no distributive property here. If you start multiplying this, it's going to take a long time, and it's in terms of square. But if you do implicitly, it's more reliable or more easier to interpret this equation. And if you substitute the answers, both the sides, you will get the same answer. You can check by substituting these two values. Here only x substitution, here x and y, you will get the same answer. So that's how we can do it. Same thing, guys. If it's cos, please make sure you remember the trigonometric derivative. Cos is negative sine. And the same thing is done over here. And you will get the same answer. The answer is 0 in both the cases. You can see when y dash of x, that's when you substitute 0, you get 0 on both the sides. Please do them by yourselves. It's the same thing. It's just explicit and implicit derivatives. So that's it. Again, I'm looking for any other different type of problems, but now over here in these problems 5 to 16, you just have to derive them implicitly, nothing else. So it's so easy now. We will do, say, one of the problem here. First over here, what happens is This is a little complicated because there's a square root and then product rule. How do you solve this? So first, when you derive it, it'll be 1 by 2 root of x and y. Then derive whatever is inside. You have to use the product rule over here. It'll be x dash, that is 1 multiplied by y plus x into y dash, minus 2 comes down to be 8y into y dash. Only when there is y you need to apply this y dash, equals 0. So you can simplify this. It'll be y plus xy dash divided by 2 root xy minus 8y into y dash. So this can be split out, distributive property. So you will get y divided by 2 root xy plus xy dash divided by 2 root xy minus 8y y dash. Take this term to the other side, keep both the y dash together. So that can be done. So xy dash divided by 2 root xy remains, and minus 8y into y dash remain. That will be equal to the negative value of this 2 root xy. Why? Because we moved it to the other side. Now here I'll just remove the y dash. I'll just write it out over here. I'm just removing the y dash outside. So what's remaining is x divided by 2 root xy minus 8y and equals y divided by 2 root xy. I just realized I made it a bit more complicated because when it goes down, it'll be complicated. Now what I'll do is whatever is remaining, I'll take the LCM and simplify this. See, now this is all correct. The answer might vary because it just depends on how you simplify it. Here, I'll just take the LCM of this. LCM in the sense, I'll multiply the denominator up and down over here as well. It'll be x minus 8y into 2 root xy divided by 2 root xy over here. That is equal to negative y times 2 root xy. Now this is all multiplication, right? So I can just take this to the other side and this cancels. See, I'll just show you, this cancels with this. Why? Because they are all multiplication. And now basically this goes to the denominator. Whatever is over here just goes to the denominator. Y dash equals minus y divided by x minus 8y. Now I'll simplify this. 8 times 2 is 16y root xy. So this would be the answer. This is a simplified answer. Let's see what is the answer over here. So yeah, it's the same thing. Now they have simplified further to change the negative sign. That's not required, but this is fine. Minus y by x minus 16y root xy. That is, say, the same answer what we got. Over here, what they have done is they have removed negative sign from here and made it positive. That's not required. You know, if you keep it like this, more than enough. This is the correct answer itself. So they have not mentioned anyway, keep it positive or negative. So this is how we solve it implicitly. You can see the steps. I'll just mark the steps over here. It'll be, this is the first step, 1, 2, 3, 4, then 5, 6, 7. You can do it in different method as well, but ultimately the answer will be same. See, my steps are a little different. Over here they have done a little different. Whichever is easy. Okay, now I just realized that I also realized that you can also try squaring initially, squaring, but it's just that you have to know it'll be more complicated, I believe. So anyways, depends on which step you use. Ultimately the answer will be same. Please do try the other problems by yourselves. Just algebraic, keep on solving, you'll get the answers. Even over here, you can see all the answers are worked out. You can refer to this. And if you want to know where you can find this presentation, please do click on the description. There's a link over there and you can download the presentation. So these are all the worked out answers. And even over here, just that, the chain rule, product rule, it might go lengthy. So please make sure you, derive each of this part properly. Understand the derivation of each and everything and then solve it up. So here also the same thing, there's square root and everything. When you just implicitly derive only one side. Now there is again, see the thing is the same thing. We did this at the beginning. Here you need to do implicit derivation. And only thing is then you need to find y dash value. So in this, there's a easy method. Now, for example, this is not so complicated. It's an easy problem. Now let's just do this quickly. See what happens. Let's derive this throughout. Here you'll get y dash minus, there is product rule here. It will be 2x into y squared plus x squared into 2y into y dash, that is equal to 1. This negative 1 becomes 0. Now minus is multiplied inside, y dash is equal to, sorry, not equal to, minus 2xy squared minus x squared 2y dash equals 1. So y dash over here, and then over here also there is y dash, x squared into 2y dash, that is equal to, this goes to the other side, 1 plus 2x x 2 y square x, it's the same thing. Now here y dash is removed out, 1 minus x squared 2y equals so much. Here you can basically stop and just substitute. See, even over here, if you want, you can just substitute the values and then simplify as well. From just this step to this step, you can, because we do not need to do for y dash, but we are just doing so it's simpler and easy to understand. Now this is the answer, right? So it's 1 minus x squared 2y. All you need to do is substitute the x1, y1, x value and y value here, and then get the y dash. Now you do not need to solve until here. You can even stop anywhere over here. Then you will have a y dash over here minus some number y dash equals so much. Then you can simplify as well. It will be the same answer. It's up to you. If you don't want to do all these steps because they're telling you to find tangent equation, you can just do implicit derivation over here. Implicit derivation is over here. This is just rearranging. And then when you substitute y dash value, you will get the answer. So that is also correct. It's up to you. When there is tangent line, you have done. So you technically must get full marks itself. This is correct. This is correct. And over here you substituted and got y dash. It's fine. But over here, you can do more, solve it more in detail and then get the answer. And the tangent line we have done a while ago, y minus y naught equals m into x minus x naught. The m value is what we are solving, that is y dash value. Here also there is a tangent line problem. These are easy itself. Just remember the formulas, how to simplify and then apply, and then you'll get the answer. Very straightforward. So that's how we solve the 19th question. There's only one more to go. Please make sure you practice more and more problems and be thorough with the topic. Finally, we are in the last question. This would be the end of the EOT for the grade 12 advance. We are nearly there, but before we start the question, I have a couple of minutes to tell a few things. So if you want, you can skip the 2 minutes or 3 minutes and directly jump to the question. The thing I want to tell you is, I want to thank each and every one of you who have subscribed to my channel, watch my videos, and would share it with your friends. I really, really appreciate it. I thank you so much. Before I continue further, I just want to tell, when you're watching the videos, please do make an attempt to write down the problems, to solve it by yourself as well. And I wish that you get easy questions in the exam, the questions which I've already practiced, and I just hope everyone gets great marks. I cannot fail to mention my own dear students, the students of Al Uruba School, Sharjah, the current students, the passed out students. Because of them, I had started the channel, the Best Math channel, and I'm very happy it has benefited other students as well. I'm so glad I've got wonderful students. They are always supportive and understanding. Just when I had some, initially I had issues with the writing pad. It was not compatible with my laptop. Without any hesitation, one of my student, Salim Saif, just the next day when he came to know about that, he bought his own writing tab and gave it to me so generously, and he was not taking no for an answer. And even now I'm using his writing tab, which is compatible to my laptop, and I really appreciate it. I've found inspiration always from my students and other students. For example, there is one student in one of the Telegram group, Razan is her name. She is so inspiring that she helps each and every student, tries her best, shares her notes, material, everything, and solves questions and helps other students to understand better. That's amazing. And please keep that going and help each other. And I hope everyone benefits from all the help. And I always used to be inspired from one of my student, Ali Yasser, who was only for 1 year. I taught him only for 1 year before he changed to another school. All this inspiration helped me to, do this channel. And I thank you all, every one of you, for supporting my channel. Now we move on to the last question. That's the question number 20. It is to understand the mean value theorem and use its applications. I will quickly solve this problem. There are only few problems here. And if you want the detailed explanation, I have put a video in the description which will go in detail. But if you want to solve the mean value theorem, it's pretty easy. You don't need to go in detail. If you just know a few things, that's more than enough. Now then, we will solve it over here. Here they have told to apply mean value theorem. We need to find a value c that satisfies the conclusion of mean value theorem for this particular function on the interval 0 to 2. Now we will solve this problem. The first condition, whether it is continuous. First one, it's continuity, continuous. Second one, differentiability, differentiable. Let's check. This is a polynomial function, so yes, it is continuous, yes, and differentiability, yes. You can write it as two statements. The given function is continuous and differentiable. So it's differentiable at the given interval, Why I'm writing this is because the exam will be right. It's better you write this out. Okay, write this statement. This is a polynomial. For more understanding, this is a polynomial function, and polynomial functions are differentiable throughout all real numbers from minus infinity to plus infinity. So yes, at this point it is differentiable and continuous. So that's done. Hence we can use mean value theorem. Okay. Now this is the statements. After this, you need to do the solving of the mean value theorem. I'll write the formula of the mean value theorem. Here, mean value theorem is given as f dash of c equals f of b minus f of a divided by b minus a. Now let's go in, the first two steps are done, right? Now let's understand what exactly is mean value theorem. If you see closely at the left side, what do you understand? This is basically this derivative, that is the slope of the tangent line. Okay, makes sense. What is the right side? This is the slope of the secant line. There are 2 points A and B. Now, what is the difference? Now, if this is the function, this is the slope of a secant line, 2 points A and B. Whereas the slope of the tangent line, it should only touch 1 point. This would be the slope of the tangent line. Now, the mean value theorem finds the value of C. C is such that you will get the two slopes, the secant line and the tangent line, parallel to each other. That point we will find out where it is, two parallel lines. So basically, if you solve this formula, you will get it. Now we have to solve f of b, f of a. What is f dash of c? We will write it in a while. But what is f of b? This is a, this is b. It will be f of 2 minus f of 0 divided by 2 minus 0. How do we find f of, first let's do 2, or f of b is equal to f of 2. Sorry, this is 2. That is equal to 2 cube minus 2 square minus 2 plus 1 Let's see the answer. It's 2 cube is 8. 8 minus 4 minus 2. It's will be 2. 2 plus 1 is 3. Now f of a will be equal to f of 0. That is equal to, it's very easy when it's 0, isn't it? All the x's dissolve to zeros. Only remaining thing is 1. Sorry, 1. And I wrote 3. Okay, this is the answer. Now what about f dash of c? First let's write what is c. F of c is c cube. Wherever x is there, just put c. Okay, what do? We just substitute these values instead of x, right? Same thing. Now here then let's derive it. F dash of c would be derivation of this. When you derive it, you'll get 3c square minus 2c minus 1, and this 1 will be 0 when you derive it. This is the answer. So let's substitute everything over here. This is 3c squared minus 2c minus 1. That is equal to f of 2 is 3 minus 1 divided by 2 minus 0. 2 minus 0. Now we will simplify. 3c squared minus 2c minus 1 is equal to 3 minus 2 is 2 by 2. So what's the answer? It's 1. Let's take this 1 to the other side. It will be 3c squared minus 2c minus 1. Minus 1 is minus 2. This goes to the other side, becomes minus 1 here. That is equal to 0. Now this is the quadratic equation. Let's find c. It will be two values of c. You can just use the calculator mode phi 3. It's fine to use calculator over here. Otherwise you have to just do factoring, which will just take a long time. So just use the calculator here. What you do is press mode phi and 3, and then we have to just put this 3, 2, minus 2 and minus 2. What's the value of c? It is 1.21 and minus 0.54. Now can you take this answer? Negative 0.54 is beyond this limit. It's less than 0. So we discard this because that's less than that, but we can write it as plus and minus. We will write it in terms of this, that is 1.21. Why I'm writing like this is generally all your answers will be in terms of like this, with the radical symbol and all that. So it is 1 plus root 7 by 3, and the other one was minus 0.5 or something. This is 1.21. This is the answer. Now, at this particular point, no, we have just found the value of c that satisfies this condition. That's it. This is the answer. C is this. Or it's 1.21. Let's see what is given over here in the... It's given as 1.7 by 3. Why the other one is not taken? Because it's not in the limit. That's why we have not considered it. This is it. This is the answer. If you have written all this and the first step which I have told, it's more than enough to get full marks. You do not need to graph. Just graphing is for understanding. Here we can see this is continuous and differentiable. This is mentioned here. Now why is this big bracket? Continuity means it's always big bracket, but differentiability we put close bracket because we have to test for differentiability. But over here, since they have just told from year to year, we just put the small brackets at differentiability. The mean value theorem then says that there is a number c in 0, 2. Yes, that's what's given. And then you use this mean value theorem. We got c value as, we got the right side value to be 1, and then the derivative just equate it to 1 and make it over here. It's a bit confusing over here, but what I've written in detail, you can just rewind the video and pause it and write it out properly. And the c value, what we got is this. So if you look at the graph now, at 1.21 here, you can see there is a tangent line, and over here the slope line. These are parallel. Okay, so that's it. Here again, you have to use the same thing, but make sure you find. See, the hypothesis is not true. You need to make sure you do the first two conditions, differentiability and continuity. Now we have studied it in the MCQ part. If you go back to the previous questions, that's the question number 12 or 13, something like that, we have dealt with differentiability and continuity. So that concept must be known. Now here, looking at this, I know at 0 it's undefined. It is not defined within this interval. So this cannot be, we can... so wait 1 second. The hypothesis is not fulfilled. Why? Over here they are mentioned. This is not defined at x is equal to 0. Don't know why they did this. In the first place itself, this is not required. You should just tell it is not continuous, it is not differentiable at x is equal to 0, which is within this limit. So the hypothesis of mean value theorem is not fulfilled. Okay, so you don't even need to do this next steps. Okay, you don't need to find the derivative or anything. This is not required. I don't know why they did it. But anyways, the derivative of this would be c minus 1 by, you can equate it, and that wouldn't make sense, I believe. C now, okay. Why they have done it is, I'll just tell you. Because even if you do the c value, it does not exist. Why? Here, when you derive this as 1 by c, when you derive it, you'll get negative 1 by c squared. That is equal to f of b minus f of a divided by b minus a. I don't think so this will be asked in the exam, because there's nothing to solve. If you just write the hypothesis not fulfilled, it's over. That's the answer, right? But over here they're just proving to show you that it does not exist. Now let's just solve this up over here. What happens? F of b is there, right? That means this is a, b. Let's substitute over there. We will get 1, positive 1, because 1 by 1 is 1, minus of what is f of a? It'll be minus 1. Again, minus 1 divided by b is what? B is 1 minus of minus 1. So you will get 1 plus 1 divided by 1 plus 1, which is equal to 2 by 2, that's 1. So here, this entire thing is equal to positive 1, I'm sorry, is equal to positive 1, not minus 1, okay? Now let's solve this up. C goes to the other side, it's negative c, negative 1 equals c squared. Take square root on both the sides. What is this? Square root of negative 1 does not exist. So this is not possible. This is another way. Even if you had applied and solved, it'll be error. Okay, you can't solve this at all. So that's why we can understand that this does not exist, because the hypothesis only is not fulfilled. Here, okay, now again over here, x squared, does it exist? No, it's not continuous and not differentiable. That's it. Even if you do, you will get an error. Over here, tan x is 0 to pi. At pi by 2, that is half of pi, it has an asymptote, right? So basically there's discontinuity. So it's not possible over here also. Why? Because see, at pi by 2, we cannot, there is a discontinuity. So no, it's not possible. It's not continuous and discontinuous. No, it does not exist. So that's the thing, because it'll be undefined basically when you solve over here. And then even over here, you can see this is a cubic graph. It's not differentiable. That's why it's not possible. Why cubic graph is not differentiable? Because it's, the graph, though it's continuous, it's like something it's a vertical line and then it goes, right? So it's not possible. It's not differentiable. So the hypothesis is not true. We cannot do, it's not different, but it's continuous because the values are continuous everywhere. Oh, this is a cube root. Yeah, cube root, it's not differentiable because of the straight line in the middle. And now we here, okay, this is C, continuous everywhere and differentiable everywhere. Here what we did at the example problem at the beginning, same thing can be done, and you will find a C value. See, the C value is there. And then this is also the same thing. Polynomial and others also, even if it is, say, a square root function, but it depends on the interval. Now when they give you an interval of 0 to something, generally 1 by x is not continuous or differentiable at 0, so you cannot use it. Even a cube root function, it's not differentiable at 0, but here it's polynomial, you can easily use the mean value theorem and solve it up. Here we have done this, but whatever I written a while ago, like that time I'd written in detail, so use that steps, okay? Write such steps in detail and then solve it up. Not only this, a little bit more detail. And that's it. Please do practice more problems, and I just wish you all the best. I hope everyone gets great marks, and please do write, practice in writing. Don't just watch the videos, practice in writing. And if you have any doubts, post them in the comments and I'll try to get back to you very soon. All the best and take care, guys.